Greetings everyone. Today we're going to explore solving systems by graphing, but I do have a few of these videos, and in this one we're only going to look at problems where we have to isolate y first and when we have one solution. Now, quick reminder, this is our third video out of this series, and just a reminder that a system is just a fancy way to say we have multiple equations that are paired together. And today in this video, we're going to talk about a specific solution, which is going to be written as an ordered pair. And what that means is those points work in both equations. So let's jump right in. In example 1, we are provided these two equations. Now I cannot graph them the way they are written. So I'm going to start with the first equation. I'm going to rewrite it. And I need to isolate y. I need to get y by itself. So remember this. Instead of negative 3x, I'm going to kick it to the other side by adding 3x. The positive y falls down, and I have 8 plus 3x on the right. Therefore, y is isolated. Let's graph that line right away. My b value, the number by itself, is 8. So I'm going to begin at 8. My slope is 3, which I think of it as 3 over 1. Rise 3, run 1. I'm off the graph there, right? Which is okay. I could have one dot off the graph, but that means I have to go the other direction. Down 3, left 1. Down 3, left 1. Now remember, because we're looking for a solution, I'm actually going to do a bunch of dots here. And then, again, my drawing's probably not going to be as great as yours. We want to connect those dots. Let's look at the second equation. I need to do a little bit of work by isolating y first. So to get y by itself, instead of a negative x, I need to add x. Opposites go away, y falls down, negative 2 plus x. Technically, there's a 1 in front of that x. My beginning is negative 2. From that negative 2, my slope is 1, meaning rise 1, run 1, rise 1, run 1. Now, I'm not going to keep going that way because I'm not going to meet a line over there, right? So let's go the other way. I want these lines to cross. So down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. There we go. Hit the jackpot. Remember to make that dot where they meet really big. And of course, my line isn't drawn the best. And our goal is to identify, oh, that was really bad though. Let me try to fix that. Our goal is to identify that point. And we want to write that point as an ordered pair. So that dot exists at negative 1, 2, 3, 4, 5, negative 5. And then we're going to go down 1, 2, 3, 4, 5, 6, 7, negative 7. So what that means is if I plug in negative 5 for all the x's and negative 7 for all the y's, it's going to work. They're both good. Let's take a look at example 2 here. I'm going to treat it the same way. If I look at this first equation, I'm going to rewrite it so I have a little space. I need to isolate y, which means instead of plus 6, I need to minus 6 over. Okay, well, y is by itself then, and I have a negative 2x minus 6. Let's graph. My beginning by itself is negative 6. 1, 2, 3, 4, 5, 6. Remember, that's your y-intercept. So you always start on the y-axis. My slope is negative 2. That means I think of it as negative 2 over 1. That means down 2, right 1, down 2, right 1. I ran out of room, so let's go the other way. Up 2, left 1, up 2, left 1. Let's carry that through. I'm going to draw more dots than necessary, just in case I need one of them later on. We're going to connect and draw arrows because these are lines. The second equation, well, I have this set of parentheses, and you kind of have two options. I could think of this as point-slope form. Let me think about that for a moment. If this was point slope form, my slope is 2, and my point would be 3, 0, right? Because nothing's being added to the y. If it says x minus 3, I write positive 3. That's option 1. Option 2 is I could isolate y by just doing a quick distribution, right? If I was to distribute that 2, I'd have 2x minus 6. That also works, right? Either way, if I do point slope form, I'm starting at 3, 0, and I'm rising 2, running 1. Or if I use my distributed 2, my slope is 2, my b is negative 6. So I'm going to begin at negative 6, rise 2, run 1, rise 2, run 1, connect, and I see a perfect intersection point right away. So my intersection point, my solution to this system is 0, negative 6. We care about where they cross in this lesson. All right, our last example here. We want to continue to isolate y. So I'm going to write this off to the side so I have a little bit of room to solve for y, because this has a few steps, right? If I'm trying to get y by itself, instead of minus 8x, we're going to add 8x. The 4y falls down, 12 plus 8x. Now I have plenty of other videos on isolating y. We've been doing this a lot this year. So if I'm going too fast right now, you might want to revisit those other videos so you get a better understanding of isolating y. What I care about more in this video, because we're beyond that, is graphing two lines. We're going to begin at 3, positive 3 on the y-axis, and my slope is 2 over 1. So I'm going to rise 2, run 1, and I ran out of room pretty quickly, so I'm going to go the other direction. I like to draw a lot of dots on my first line because I have no idea, whoops, I'm not good at this today. I have no idea where my other line is going to exist. So the more dots, the better. Let's take a look at the second equation. Again, I'm going to rewrite it so I have a little bit of space. First of all, instead of plus 2, we're going to minus 2. The negative y falls down. I've got a negative x minus 2. Now, there's technically a negative 1 here. We still have a negative. We have to divide every piece by negative 1. Y is by itself. Negative 1 divided by negative 1 is positive 1. Negative 2 divided by negative 1 is positive 2. Let's begin at 2. 2 on the y-axis, that's my beginning. My slope is 1, rise 1, run 1. Well, I'm going away from the line. That's not helpful. So let's go the other direction. And when I go the other direction, look at that. Battleship sunk. There is my dot that is shared by both lines. Sorry, I'm bad at drawing lines today. So we need to identify that dot. That dot exists at negative 1, 1, meaning left x, up on the y. All right, so I know this is a short one, but every topic in this we have already spent plenty of time on. We have isolated y many, many times. We have graphed lines in slope-intercept form many, many times. The difference in this particular lesson is acknowledging that we're looking for a nice clean point where they cross. Make sure, as always, that you check out Google Classroom to see what the task is to go with this video. If you were on the wrong video, take a look at my YouTube playlist. And until next time, have a good one.